So today I'm gonna show you how to program this tiny analog sensor. We'll do it from scratch without any libraries or any modules, and we'll use only its datasheet. This tiny analog sensor is a temperature sensor, TMP36. And I said analog is because it uses analog voltage on its output, on its middle pin, and that means that voltage will change through time whenever the temperature changes. And I will program this sensor using this board, and this is Raspberry Pi Pico. And also I will use Python, actually MicroPython, to program this microcontroller here, RP2040, and this board. But of course, the formula that we will derive, you can use on any microcontroller, program it on any programming language. So it's not used just for Python, MicroPython, or this board specifically. And of course, also we will need a breadboard and some wires. To be specific, 3. So I've got white, black, and orange. White I will use for power supply, power voltage, to power the sensor TMP36, and black I will use for ground. And of course orange for signal, voltage output from this sensor. So let's go to computer screen, and I will show you datasheet, and we'll just go through that, derive formula, and then come back here to connect this sensor. And of course we'll see the pinout for this sensor, how to connect this sensor. So I've installed the datasheet for TMP36, and here we can see TMP35, 6, and 37. These are just different models for this temperature sensor. And the main thing that we can see here is the operating voltage. It is 2.7 to 5.5, and we will use 3.3 volts. I'll explain later why. And the other thing is that it's calibrated to display degrees Celsius. So if we go a little bit below, we can see the general description for it. So here we can see that these modules, these sensors, are temperature sensors that are providing voltage output. So it'll be the middle pin of our voltage. So here we have the not schematic, but drawing of it, and it will output the Celsius, temperature in degrees Celsius. The other main thing, very useful information here, is that it's linear proportion. So that means that voltage output versus Celsius is linearly proportional. And this information is very useful because if we go down a bit, we can see the graph for this module, for this sensor, and for its temperature versus Celsius line. We can use the equation of a line where y equals mx plus b. So on the right side we have our temperature sensor, and we can see here that it is a bottom view. So that means legs are pointed at us. If legs pointed at us, the left leg, which is 1, will be power voltage that will supply to this sensor. And if we scroll down to page number 5 here, we'll see this graph that tells us what is temperature versus output voltage of this device will be. What this graph tells us is that, first of all, we have 3 lines that are for TMP35, 36, and 37. We only need 36, which is line number B. Just B. Next, what we can see here is that the test conditions that were provided, that this sensor was tested with, it was 3 volts of power supply, and that's actually why we are using 3.3 volts for this sensor. So if we use, for example, 5 volts, I don't think it will work. So now let's just take this graph, and I will show you how to derive formula that we will use for our microcontroller to calculate temperature. First, what we know? We know that this line is it's line. So output voltage versus temperature is a linearly proportional relationship. That means we can use equation of a line. Equation of a line is y equals mx plus b, where m will be slope of a line, or it'll be y2 minus y1. So this is the coordinate on axis y, divided by x2 minus x1. And what these coordinates mean is that y2 is the furthest from 0. So if we go to the right in this direction, y2, for example, will be, let's say, for sake of discussion, 75. That means y1 will be less than 75, anything less. So 50, 25, something here. So that's just how we define y2 and y1. And of course, same for x-axis. Now, here is the most important part. We'll use this graph a little bit different that we used to. So here, what is y? Y is some value that we want to find. And x is some value that we already know, that is given to us. So what will be the value of y? Y will be temperature. We need to find temperature. What is the value of x? We need to find, we know output voltage, because this is what the sensor, temperature sensor, gives us. Depending on temperature, its value of voltage will vary. So that means it gives us a voltage, and we know voltage. And what does this mean? This means that this axis that goes vertically will be our x-axis. The temperature axis that goes horizontally will be our y-axis. Now let's find m. What will be the value of m? As we discussed and as we wrote the formula here, we need two values, y1, y2, and we need x1 and x2. These values can be anything, like literally anything that you want from this graph, of course. So y2, I want to have as 50. Why 50? Just because it lies here and it is very, very easy to find. So if we have this point and we just go straight down, we will see here 50. And 50 is our y, but this will be y2. What will be x2? x2 is same corresponding value. So if we have from the same point, go to the left, we'll see that x is exactly 1. So that's why I chose this point, because it's very easy to find. So that means y2 is 50 and x2 will be 1. Minus, minus. Next point I've decided to take is, of course, it needs to be, if we look at the y, we need to go this direction to the left. And I've decided to take this point. Why? Again, because this is very, very easy for me to identify it. So on the x, we can clearly see that it equals to 0.4 volts. And if we go down from the same point, we can see that it is maybe exactly, maybe approximately on the middle between 25 and 0, which of course will equal to negative 12.5. Now plugging into the formula, 50 minus negative 12.5 divided by 1 minus 0.4. So what we'll have here? Here, of course, 50 minus 12.5 will be 50 plus 12.5. That means it'll equal to 62.5 divided by 0.6. So this is our m value, or it will equal to 104.667. Next, we need to find b. To find b, we will do this. We take our initial formula and we plug in values that we know. So for this example, you can, of course, choose your own values, whatever values you want, but I will use for y, for example, 50. it will equal to m. M, of course, we know it will equal to 104.667 times x value. X, when y equals 50, x will equal to 1, and plus b, this is actually what we want to find. So here 1, we can just cross it out because anything times 1 will be same value, and that means b will equal to. So here we have plus. That means if we want to place it to this left side, we will change this sign to be negative. That means it will equal to 50 minus 104.667. And our b is equal to negative 54.1667. So here we go. We have b, we have m, and we can find formula. So the formula will be just y equals to m. M is 104.667 times x minus or plus negative value, which is same as minus 54.1667. So this is the formula that we will use, or that we will code in our microcontroller to find any value for y, and y, we know that it's temperature. So here. Okay, finally we can start coding. I will code in the development environment called Thony, which is very easy to code in. It is very easy to use with microcontrollers. So what we do, we just click download for Windows, Mac, or Linux, whatever you are using, and whatever version of Python you want to use. After it will be installed, we create a new Python file, we open it using Thony, and when we open it, we'll see this IDE, or just this window. So first we need to import some libraries, some modules. First one is to have a timing. We'll use it a bit later. Second is import machine. Machine is a module from MicroPython, I think, that is that gives us ability to work with microcontrollers, inputs and outputs. So it's very easy to use. Then we define a new function. Of course, you can do it in just a loop, in main loop, but I've decided to make it a function so that it's easier to understand for us. This function will take in the argument of voltage. This argument we will read from microcontroller, from the TMP36 sensor, and pass in here. Next, using the formula y is equal to mx plus b, where y is temperature and x is voltage, we plug in our values for m, then for b. And after that, we'll just rewrite our formula, y equals mx plus b, using this. We will use this variable temperature, will equal to m, which is this one, this value, times voltage, which is our x, or we take this voltage from here, but this voltage that we're passing in our function will define a bit later, plus b. And this function should return this same variable that we are calculating here. So that means when we ask this function for the value, it will give us this value, which is this one. Next, we need to define the ADC input, or analog to digital converter input. So this will be GP26 or ADC 0. This is from datasheet. And ADC we are connecting here because our voltage is analog. We need to convert this voltage to some digital value, which will be represented using 0 or 1. And these zeros and ones are what computers can understand and can work with, make calculations with them. Because otherwise computers don't understand our real world analog values. Next, we create a loop, which is a while true loop, and it will just run forever so that we can have our readings of temperature essentially forever. And after that, we need to read this ADC input that we defined here. So what values do we have on that input. So we will use this statement right here. We'll have this ADC value that is converted. And next, after that, we need to convert our ADC value that is computer reading back to voltage, because this is essentially what we need. We need voltage. We're using it using this formula. So this our ADC value that is computer interpreting. Here we will multiply it with this value in parentheses, which is 3.3, our voltage, divided by 65,535. Then this value of voltage, of course this is not actual voltage from our temperature sensor as we discussed earlier. This is voltage that is generated by using this ADC value, and we need to just a little bit do a little bit conversion to make it seem like voltage, analog voltage. Next, we create a variable that is called temperature. So essentially this variable is not same as this variable. This is totally different temperature variable, but I just decided to call it same as we have in our function. And we assign to this newly created variable this function that we just created, which will return to us this value, temperature, that we are calculating here. So essentially I'm saying whatever you calculate here, assign it to this value, to this variable. And then we will pass this voltage that we just calculated, generated, to our function, calculate temperature. And these two variables can be named differently or same, whatever you want. Next, I'll just print this value to our console or here, and we'll print it every 1 second. Okay, so the code is done. Now we need to connect our circuit, and I'll come back here after we connecting to start our program. Now let's connect this sensor and we'll see if it will work. So remember, it will look like this. The legs are pointing at us. That means the left side, it will be power or 3.3 volts in this case. Then the most right pin of the TMP goes to ground, and the middle one we connect it to GP26 or ADC0. If we're using the board number, it will be number 31. So this is the most upper right pin is 40, then it goes 39, 38, and so on. Okay, I will also need this wire, USB cable. So one will go to here. This is USB, I think micro or mini, I'm not sure. So before we are connecting, we need to install special programming language on our board, microcontroller. So it'll be MicroPython. So how do we do that? First, we connect this to our computer, and then while holding this button, hold it until I say you can unhold it. So we'll hold it, press and hold, then connect USB, just wait, and okay. So now on my, you can unpress it. On my computer, I have opened a file for this files for this board. So I'm gonna switch to the computer right now, and I'll show you what do I have. Okay, so this is the file that was opened on my computer. So you can see here rpy-rp2d, and here you will have two files, index.htm and info.uf2.txt. We don't care about them for now. What we need to do now is to just minimize this window, and we'll go to this website. Link will be in the description, micropython.org, and we need to install MicroPython. Here at the top, at the navigation bar, we'll see download, and if we scroll down, we can see different boards. We just need to find our board, which is Raspberry Pi Pico. It should be, yeah, here, Raspberry Pi Pico. And of course, you can see here also Raspberry Pi Pico W, but we'll use Pico. Then we scroll down and we see the latest release. So we click here, it will be installed. Now here our file. Then what we do is just, we have our initial window opened. Then we have installed window that we have this file. So we just drag and drop this file to this folder. Then we wait. Okay, after we installed it, we go to the right bottom corner. Here, we can see some text. It will be different for you. So we click on it, and we can see here our Raspberry Pi Pico. So I don't know why there are two of them, but we choose Raspberry Pi Pico. And here we go. This means that we have installed everything correctly and everything works. So let's just first start this or run the script, and we can see temperature. So I think it is quite accurate. Right now in my room it is approximately 24-25 degrees. Of course, don't forget this is in Celsius. If I try to make it hotter by squishing it between my fingers, we can see 29, yep, almost 30. Yeah, so we'll have a bit around 30, 32, something like that. So yeah, it works. Now, if we want to run this script without even this IDE, Thony, where we can just plug in the USB into a cable, into a phone charger, what we can do? We can do this. Go to File, Save As, and we need to save it on our Raspberry Pi Pico. Now, here I have a lot of things going on. You will not have this file, and yeah, we will use this main.py. So what we need to do is to save it as main.py. This is mandatory. This is what you have to do. And when we save it, we will see our file in these square brackets. That means whenever we power our Raspberry Pi Pico, it will start this code or whatever you saved it right away without any opening of Thony, playing run script, and something like that.